We need a calculator person today. Who's that gonna be? Yes. 5. 1, 2, 3, 4, 5. Hayden, you wanna be a calculator person?
Yeah.
Excellent. Okay, so most of this one is all about growth and decay. The word decay is not necessarily perfect here. If something is growing at an exponential rate, they usually just call it growth. If something is going downwards at an exponential rate, they refer to it as decay, even though, I mean, like, decay is kind of more for when something is, you know, dissolving or whatever it be. And then there's a third formula up there about compound interest, which compound interest pretty much only applies to money. And so usually it will be semi-clear which one of the three problems you're going to be working on because of what they deal with. If something is growing, generally going to be growth. Frequently in the problem, they'll use the word growth or decay, and so you'll kind of know which one of these two it is. Hi.
Are we going 1 day or 2 days?
For Unit 6?
Yeah. Going 1?
I put 1, but I don't really care.
Calculator, no.
I also don't care. I'll just tell them to be prepared for whatever. I don't remember what I was saying now. Either way, let's try some of the problems together. Okay, so it says the world population in the year 2000 was about 6.08 billion. The annual rate of increase was about 1.26%. A, suppose the rate of increase continues to be 1.26%. Write a function to model the world population. The word function just means write an equation. Okay, so the equation up here for growth is what we're going to use. And then B says let x be the number of years past 2000, find the world population in 2010. So it's kind of like two questions, but it's all one question. Okay, Hayden, somebody's going to help me try to write an equation. Who's that going to be? A number's fine if you don't want to call on a person. Caitlin?
Yeah.
So number 1.
Yeah.
Caitlin, are you ready? No, but we didn't do anything yet. Now, I'm gonna guide you, is that what you're kind of slightly worried about? Okay, so for this problem, we're gonna use the growth formula, okay? And if I write down the growth formula, there is only a couple letters in it. Okay? A is gonna be the original number or original amount. So in this case, what's our starting amount of people? 6.08 billion. And we don't have to write it as the super long number. We could just write it as 6.08, and then our answer will be in billions. Okay, good. We've got a good start. 1 is just part of the formula. R is the how fast it's growing, the percentage rate. Perfect. And then do you remember how to write 1.26% as a decimal? Okay, so 1.26% as a decimal, you're gonna move the decimal over 2 spots, and it's gonna be 0.0126. And then the T stands for how many years. So this one says we started in 2000, planned population. In 2010, So the number of years will be 10. No, just 10. Because if we start counting in 2010 would be 10 years later. Okay, Hayden, that is what we type in. We'll just call it 6.89 billion. These problems aren't gonna be too bad. I mean, the hardest part by far is just like probably having to write the formula down first and then putting the correct numbers in. You don't have to memorize the formula, you don't have to like come up with it on your own. Caitlin, are you ready to pass on the torch? Okay, you did great, see, you did just fine though. How about a number? 1, 2, 3, 4, 5, 6, 7. Alan, you are 7. You look excited to be number 7. Okay, you buy a computer for $6,500, which should be a good computer. It says it depreciates at the rate of 14.3% per year. Let's start with the word depreciates. Have you heard that one before? Okay, does it mean bigger, smaller, up, down? Down, correct. So depreciates is gonna be a word that stands for decay or getting smaller. So we're gonna use the decay formula because the word in the problem is telling us the answer's getting smaller. So I'm gonna write down the decay formula from up top, which is similar to growth except it has a minus. Okay, Alan, all I was really hoping you could do is just help me fill in the numbers. So A, how much did we start with for the price? 6,500. For the most part, all of these problems really are only gonna have a couple numbers in the problem. So that's what you choose from. Okay, so then we got 1 minus, and then how do we write the percent as a decimal? Close. No, wrong direction. If I move the decimal 2 spots, it would go right before the 1. So it's gonna be 0.143. Oh, here, B. I was trying to find the number of years, but it's written in part B. So then what do I put for time? 3. Excellent. And so after 3 years, this computer will be valued at 4091. How many cents? 0.24. Excellent. How are we feeling about these? I mean, like, I feel like once you understand what you're trying to do with them, they're not bad at all. Okay? I need to go to a different page, because I believe the bottom one, yeah, the bottom one isn't the money one, and I don't think there's a money one on. Okay, those are money, but they're not bank account. And I wanna say that's on the 3rd page. Yeah, okay. So we'll do this problem, I think it's top of the 3rd, page 7, top of page 7. And Alan is gonna let us, Alan, who are we gonna choose? Jackie. Jackie, he didn't even choose a number, he just went right. Okay, what's the formula for compound interest?
Y equals A, and then parentheses 1 minus R over N.
You sure it's minus?
Yeah.
Should be plus. It says minus in the packet. So it would be a minus, if it was a negative percentage, like if you lost money. But generally, this one is just gaining money. Okay, so good thing we ran into that. So 1 plus R over N, you said?
And then, the exponents are N times T.
Perfect. Okay. Now, this formula looks a lot worse, because it has more things. The only difference though is this N. This N is the number of times compounded per year. Okay, what's the amount we start with for money?
1,000.
Okay, $1,000. So A is still the same. The R is still the same, that's a percentage. So do you remember how to write this one as a decimal?
0.072.
Perfect, you move it over 2 spots, so it's 0.072. And then, here's where I wasn't sure if you guys knew what the words meant. Annually, how often does that happen?
Is it once
It
yearly?
is. Annually means once a year. Probably the most common place you hear annually or annual is either A, flowers, because they have the flowers that bloom annually. And then there's festivals, you know, like, the only one I can think off the top of my head is the Irish Festival, they have the same fall every year.
Winter carnival?
The Winter Carnival, sure. What's the Woodbury Days? What's the one up in Cottage Grove called? Strawberry Fest? Yeah, Strawberry Fest. Things like that. They only happen once a year, so they usually just call them the annual. State Fair. Why didn't I think of that one? That was probably the easiest one. So, in place of N, how many times does it happen per year?
One.
1. And then I'm gonna put 1 in place of N again, and then T is number of years or months or whatever we have. 5 years. Okay, nice job, Jack. And then Hayden, I don't know if do you know how to type this one in the calculator, okay? That sounds perfect. It was gonna be bigger than 1,000, but not like a terrible amount. 415?
Yeah.
And how many cents? 0.07. Okay, perfect. And that sounds correct to me, so it makes sense. I knew the amount would go up. I knew it started with 1,000, so like if I got an answer that was like 18 million, something went wrong. Good. We're not gonna do this problem together, but maybe we should write down here what quarterly means. I bet somebody probably knows. How many times a year is quarterly? 4 times a year. Like if you think of quarters, if you have something, well, a quarter is 25 cents, it's 1/4 of a dollar. Either way, quarterly is 4 times per year. So when you're doing that problem, I feel like that's the only one. I think these were the only 2 in the whole packet that had compound interest. And I wanted to make sure to point them out to you, because they weren't on the first 2 pages. Okay, today's a full day. Oh, sweet, I didn't even check to see if the, not the clock, schedule was correct. So we're gonna go to 26. Now, I have a feeling a lot of our time is gonna be taken up by people either asking questions on the worksheets that they tried, or turning them into me. Because very few people turned them in through Schoology. I have definitely heard that the new Chromebooks are no good for taking pictures of turning in. So I'm guessing the people that turned in probably did it from their phone. And I also know that the Schoology app for some people just doesn't work on their phone right. That's how it goes. So, you're always welcome to turn them in just directly to me, to show them to me. So I have a feeling a lot of people were gonna do that today. So, what I wanted you to do is to do pages 5 and 6. Which, we've already done 2 of the 3 on page 5. So you basically have 4 questions to do. And I will gladly help you with anything you want. And I will gladly put anything in the computer that you have. But as a reminder, I'm not here tomorrow, so that's why I wanted to make sure to take care of everything today again. Tomorrow is when the city of Woodbury made me stay home. Which I was annoyed with, but at the same time, I was okay. So, I don't know, I wanted to make sure you guys were all set for tomorrow. Tomorrow you'll have an assignment on this as well. We good? Okay, excellent.